Good afternoon, everyone. Every week I review all the cases that come in from our customers into the Azure Support. And one of the things I do is I look for trends that are affecting all of our engineers on their ability to help all of our customers. Some of the things that I look at are, what are the big issues that are coming up? Was it something in our infrastructure? Was it the way that the customers deployed their infrastructure in Azure? Or was it just common human error? You went through the portal, you're selecting your VM, where you want to deploy it, you select the region, you select your NIC card, but you're adding to your existing already, and on error you went to the wrong region. So those are all the things that I look for on how to improve the customer's knowledge and to support our support teams with really what's going on, how can we improve our overall performance for our customers. Some of the things that I found were the deployment practices, that there was many inconsistencies in the way that our customers are selecting to deploy environments. Some do use automation, but when they go back to do patching, they're manually patching individual servers. When they're going to add to their environment, they're manually adding 1 or 2 servers. They're adding an appliance, and everything is in a manual process, and we found a lot of issues with that. They're going to make changes to the configuration, and they're going into the portal and doing it manually, and then all of a sudden they lose connection, they lose access to VMs that maybe were encrypted. And so there's so many scenarios that if they went and used automation and set up their Terraform configs or their Ansible runbooks, they could literally go into the configuration, make minor changes, QA their changes before they run them, and every single time they run these automated scripts, it's going to give them the same performance. And this is one of the things that really drove me to come here today, is to share our findings with you and to show that you can launch any environment. We're going to do a demonstration on a small scale because of the time we have, but it's really such a practical and smart way to do your deployments. Why would we want to automate? First of all, I was with Skype for Business many years ago, and it really ingrained in me the need for automation. As we build large enterprise infrastructure globally, there was no way we're going to send an engineer to a data center or to a local company to build out 50 machines just for that region. Instead, we built out our scripts, we tested them, we deployed with them, we patched with them every single time without fail. So why today, almost a decade later, we have cloud environments and people still use manual process? Doesn't make very much sense. So we really want to save our time, save our energy with scripts and automated tools. Now Azure does have several other ones. We can use ARM, but since I'm with the Linux environment, we really liked what our partners are bringing into Azure, so that's why we're really going to focus on Terraform and Ansible. One of the other things is the amount of overhead that it's going to cut down on. If you have your automated scripts in place, yes, you do have to set them up, and that will take time. But once they're in place and you want to deploy again and again, make updates, do changes to your environment, simply modifying your configuration and launching the automation is going to take care of that for you. And lastly, we really do want consistent performance. We don't want to be launching a VM and, oh, did I have a quad-core VM, and you launch it and then realize, oh, I had a 32-core, no wonder my performance is horrible. Again, you won't make the mistakes. You don't have to know exactly all the configurations for your different workloads around the world. Use your templates. It can launch to the regions, to the specific workload you have, and really make it consistent throughout your environment. When will you benefit? Well, some of the key ones that I always thought of was scaled resources. Parts of the month, you're doing reporting, you really need to have that big, robust system for your SQL environment. You want to just scale up, have 200 more VMs, increase your storage capacity. Now it's the beginning of the month, reports are done. You don't want to keep paying for that. So let's scale back down. Automation is a great way to do that. It will not only build the infrastructure for you, it'll scale it up for you, and it will decrease it down for you as well. The next thing is your configuration. As I said many times before, once you set your configuration in place, it's always set, it doesn't forget, it doesn't change until you go in and make your modifications and do your QC. QC is a very important part, ensuring that your configuration was created correctly and that it's maintained correctly for all your many deployments. And finally, orchestration. We want our scheduling to be tight. We want our affinity, anti-affinity to be correct, so when we're scaling out to make sure that if we need our resources, they're there. If we don't, we need to be able to scale them down. Our health monitoring, failovers, all of that can be done through orchestration using automation. What are the differences? Well, with Ansible, it's really an open source provisioning configuration management application software. When you want to set up your configuration, do Kubernetes deployment, do the Kubernetes configuration, Ansible, we found, has been a really great tool on managing that for you. And also, when you're doing updates, patching, even version changes, Ansible has been the spot-on tool that we found for our customers to do those type of deployments. Terraform has been more on the infrastructure provisioning tool. When you do your initial deployment of your infrastructure, we found Terraform is the way to go, because let's say you have your storage in Azure. So that's great. But you're also running some databases in Oracle, and you have some other services that you need to draw from that are in AWS. With Terraform, it speaks to all cloud services, and you'll be able to do your deployment at the same time. Tear it down, build it back up. It will talk to all services and really speed up that deployment time for you. Finally, I'd like to go ahead and turn over our demonstration to Arun. He's one of our software engineers, and he will take this portion on.
Hey guys. Before I continue with the demo, I just wanted to know how many of you deploy VMs in Azure on a weekly basis and not use automation? Can I see some hands? Oh, okay. Then this session is specifically for those guys who use automation to an extent or don't use automation to a full extent in Azure. If you don't use automation in a cloud like Azure, you're missing out the true capabilities of a cloud like Azure, like the deployments and the ease at which you can do the deployments. So if there is something you can take away from this session or the demo, these will be the two key points. And these key points are for multiple customers. We have seen over the years, the recommendation would be to use an automation tool to just get rid of these 2 points. The first one is having a desired state config. So most of these automation tools like Ansible or Terraform, they make sure that your environment is reaching the desired state every time. So you define your in a code, and this automation tool makes sure that your environment, your Azure environment, is as defined as in the code. And the next one is ease of deployments. We have seen customers where they say that they don't have enough test environments, and multiple developers from different teams share the same VM. And the reason for that is they say they are not able to spin up enough test environments for their developers. So using Ansible or Terraform or some kind of an automation tool, the ease at which you can deploy is fascinating. We have seen some really customers who use the automation to a full extent, and I think Ron will be sharing those stories at the end. And so what are we going to build? In this particular demo, I'm going to deploy a Kubernetes cluster, and I'll be showing to you guys like the two pain points what I was pointing, like having a desired state and the ease of deployment. So in a very simple terms, a Kubernetes cluster with a one master node and 3 worker nodes look like this. But in our demo, we'll be deploying 3 master nodes in a high availability and 3 worker nodes. And if someone is not aware of Kubernetes, it's like an orchestration solution for containers, which is getting more and more popular. So an oversimplified diagram of this would something look like this, or the demo what I'm going to build. So we have like 3 VMs, which are the control plane parts, which will be the master nodes. And on the right side, to my right, it's like the worker VMs, which will be hosting these containers. And we also have some subnet, the VNet configured, and also for the firewall rules, and also have a load balancer. So if you see this environment, if you want to deploy Kubernetes, it would take somewhere around 90 minutes or so for the first deployment. And if you want to do the subsequent deployments, it might take 60 minutes because you got used to the process. But what if you want to deploy this environment whole day with hundreds of VMs? It's not possible for a guy or someone to do this task again and again over the day. So how can the automation tool help in to deploy these kind of things? So in our demo, we'll be building this whole infrastructure using a Terraform template. And once the template and the infrastructure is built, we'll use Ansible to configure different components of Kubernetes, like configuring the control plane, configuring the worker plane, and also configuring the pod networks, like the communication between the pods and everything. So this demo usually takes like 15 minutes. And if you want to scale to like 100 nodes, it might take 25 minutes. But that's a huge improvement when you see if you want to deploy something manually. And the other thing, the main advantage of using an Ansible or Terraform, and this is you can write checks in your templates, making sure that once this deployment is done, it's production ready. You don't need to invest a lot of man hours for testing the QC part and then going to the production. I think it's enough of talking. I'll just go ahead and start the demo. So if you have an automation, like you can put all your automation templates in a CI/CD pipeline, and you don't even have to log into the Azure portal to deploy something. So in here, I have like 2 things. One, for the demo purpose, I have like Ansible and the Terraform. I will use Visual Studio Code to deploy my whole environment. Okay. Visual Studio has some cool features, like it has extensions for Ansible, Terraform, and also for the Cloud Shell, which I'll use to build this whole infrastructure. So I'll just go ahead and run the Terraform first. And while this code is running, I'll just skim through the code just to show you guys what are the different components in it and how it's going to build. So if you press like Control-Shift-P, you'll have the different options, and I'm going to select Bash shell for the Cloud Shell. This is the same shell you get in the portal, and also when you go to the shell.azure.com. Okay. So we have a persistent storage for the shell, the home directories of the users, along with a cloud drive. It will create a cloud drive and is backed by the Azure file share, which will be stored in your storage accounts, so that the same cloud shell you will get in multiple devices. So there is no need to save data in a very particular device. You can use a browser just to go to shell.azure.com, and you'll get the same entities what you have saved. I'll now navigate to the cloud drive. And I have this ignite.demo. And as you can see in my GitHub, like I just pulled this like a minutes back before this thing. So I have both Ansible and Terraform. I'll navigate to the Terraform directory. So I have this main.tf file, which has all the configuration for the infra part. I'll initialize this directory. So the Terraform will make sure that all the config files or all the Terraform related files are initialized, and the resource providers what this particular config file is going to use, it's going to fetch all those things. Okay, I only have the Azure RM provider in my Terraform config file, so that's the only one I have. So I'll go ahead and run the Terraform apply, which will create all the infrastructure what I need to build in Azure. So we have like 33 different resources for a single this Kubernetes cluster. I'll go ahead and type yes for this. And Terraform will now build all different components which are there, which are needed or which I've defined in my code file. So I'll just quickly go through that code of how the Terraform code looks like, config file looks like. Okay. So this is how a Terraform config file looks like. In this, we have a basic syntax where you define a resource, followed by the resource provider, and the name, which I defined like K8. So this first block, it actually creates a resource group. A resource group is a logical entity in Azure in which we can pool all your resources together. So my Kubernetes cluster is going to be created in a resource group. So you can see in these two things, I haven't specified the names anywhere. It fetches all these things from a variable file, and that would be, if you go to the left, I have this variables.tf. So in this variables.tf, you can define multiple files. Like, so if you want to define the ports, the regions where you want to deploy, the number of VMs you want to deploy. So in this example, I have just used 3 control VMs and 3 worker VMs. As you can see in the down, this is just a number over here. So if you just increase this number to 100, Terraform will deploy the 100 VMs at the same time. That's what I was telling about the automation tool capability. I'll quickly navigate to the main.tf just to show the different resources what we have. So it creates a network security group, which is highlighted, or which is this one, and it will allow ports 22 and 6443 for the Kubernetes, and it will create a virtual network. It will associate the network with the virtual network. Let me just take a quick look at how the deployment is going. Okay, and it's a very basic syntax. Like, you just define the resource providers, and followed by the name, and you define your custom parameters, like how you want your code to be or how you want your infrastructure to be, and Terraform will take its course, and it will build all the things like configuring the public IPs for the VMs, and here we are configuring a public IP for the load balancer, for the control nodes, and if I skim down, it's creating public IPs for the worker nodes, and over here it's creating a load balancer. Skim down, it's actually creating a backend pool, and it's also creating a load balancer probe. We have few rules where we want to just place the control nodes behind the load balancer, and this is some rules to configure them. The network interfaces we want to create for this 3 VMs, and I have defined my own private IP range and everything in this code, but you can also do that via variable file. So it defines an address pool association. And this is the network for the worker nodes. And all these control planes and the worker planes are in a two different availability sets, just to make sure like all these three VMs are in always in a high availability, or if one goes down, Azure will automatically make sure that the other two are up. And finally, we are creating 3 virtual machines for the control plane. I'm using Ubuntu, and this is all the details about them. And finally, the worker VMs. So I'll just navigate to the Azure portal just to show you guys like what is being done in the backend, so that you can get an idea of. Home, I'll navigate to the resource groups. This particular demo creates a resource group named Kubernetes. So here. And these are the different resources, the VMs, the different entities I was telling you guys about, which Terraform is building currently in the backend. I'll just go back to Visual Studio to see the status. Okay, so I think it hardly took like 2 to 3 minutes or something to create the whole infrastructure. And I have a small copy script for the next part, which is for the Ansible to create a host file with all these entities which I just created. Okay, now the part with the Terraform is done, so it has created all the infrastructure. Now I'll go into the Ansible and I'll run the Ansible playbook, which builds all the Kubernetes, or which configures the Kubernetes infrastructure. I'll navigate back to Ansible. And over here we have all the playbooks. I'll go ahead and run a playbook named K8, and I'll go through the playbook contents once this is running. So. So this playbook runs for at least like 9 to 10 minutes, what we have seen. So in between that time, I'll quickly just go through the different tasks, what the playbook does. So you can see like what it's building actually in the backend, or what it's configuring. So I have this k8 build.yaml file. And these are the different playbooks what this k8 build is pulling up. It's installing all the required packages. It's configuring Docker. It's running kubeadmin, which is kind of utility to install Kubernetes. It's configuring the control plane. It's configuring the worker nodes. It's making sure that the kubelet service is running, and it's also configuring the private IPs for the pod networks. So this whole task, if the Ansible playbook task itself, if you do it manually, it should take at least an hour or something for someone who is well aware of configuring Kubernetes. So I think it's going to roll out for like 9 or other minutes. I'll just take some questions if you have in between.
So if you guys have questions, we're actually, go ahead.
Yeah, I was curious, if you can't access with a pip, can you use Ansible? So for example, if we have ExpressRoute, we're using all of our servers as being NATed IPs, and we don't actually have a one-to-one NAT for every virtual machine. Can you use Ansible in that case, or is another tool better?
Yeah, so from the Cloud Shell, you can connect to one of the VMs in your ExpressRoute circuit, so that you can, in that way, you can have the connectivity without even having the public IPs. Is that the? The Cloud Shell actually has the binaries for the latest binaries for Ansible and Terraform. So
Okay.
You can connect to the Cloud Shell, then you can access all your VMs.
Okay. So if we were trying to do everything with GitLab CI/CD pipelines, where we're using runners or Terraform runners, GitLab runners on a Terraform server, pushing this stuff out. After that, the orchestration piece finishes. We now have a generic Linux server. Are you saying that we could use the Cloud Shell to do the rest, tied into that CI/CD pipeline?
I mean, for this demo part, I've used Terraform only to build the infrastructure part, and Ansible to configure the entities. So I didn't get your question properly, so maybe.
We'll get with you later.
Yeah, thanks.
So those of you who do have questions, later we actually have Red Hat and HashiCorp here that they brought some of their leads for Terraform and for Ansible, and we'll be able to answer your questions if we don't get them during the demo. So some of the larger companies that we've seen them using automation, we actually worked with Milliman, and they need to run large test environments that they only needs to spin them up, run all their tests, verify them, and then spin them back down. And Milliman currently spins up about 3,000 VMs using the automation tool, using Terraform, was it? Yeah. They use Terraform to spin up all the VMs and run their tests, which is one of the larger instances where we see them just spin them up and taking them down all in a very short period of time. They literally will do them in a day's time frame, run their tests, and then tear them back down. We also had Staples, who was doing the automation as well. And we had come to one of the cases that came in from them, found out that on the platform side, when they were doing the configuration, that if they don't set the configuration up right for the resources, then even using automation, you'll run into issues. So that, again, that's the point where I was talking about that when you're setting up your configuration, you really want to QC it and make sure that you're setting the right regions for your right payloads. So when you're running the automation, once we found the issue, worked with them to correct the config, and then they were able to do their mass deployments. What was one of the?
I think it's like another 5-6 minutes.
Okay.
Go through the other slides, what we have, the portal and everything.
Which one?
The customer success one.
Oh, yeah, I can.
I'm sorry.
Is it on? Okay, thanks. So we've done a lot. I'm with Red Hat. We've done a lot with the automation pieces. So what do you recommend? Where would you recommend running a lot of your configuration management pieces from? I think the gentleman had a point, was building pipelines and pushing things out. But where would you run this? I know obviously if someone's kicking off tests, maybe a pipelines are correct, maybe your laptop is correct. But if I'm continually running automation against something, what do you suggest, or where do you suggest we run that from?
We have seen recently a lot of customers using Azure DevOps for using the CI/CD pipelines and pushing the things. But we have also seen other tools like Jenkins and others where they push the code using the CI/CD pipelines. Yeah. But the Azure DevOps has this feature of integrating most of the things in Azure and also the open source community. So we have seen customers. Yeah. I think
How's it going?
Hey.
Yes.
Just real quick, one of the challenges we're having, we're starting to use Ansible more and more for a lot of our Linux VMs and do the code first approach. But one of the challenges we're having is with patch management. So we have some PCI applications that we're using infrastructure as code around, and we're struggling with a standardized way to manage patching these systems in a way that satisfies securities compliance requirements and getting them into our playbooks in a manageable kind of way so that when we're tearing down or rebuilding, we're rebuilding with the current set of patches that were on that VM at that point in time. Is there That's an open-ended question, by the way. There's like, for anybody who's doing that. Yeah.
For the deploying patches.
Yeah, so they want to deploy back on the same version after you do the security updates?
Well, yeah, because if I'm updating module versions and all that kind of fun stuff, if I'm doing my automated testing or repeated builds or whatever on an outdated image or an image that's not using the current versions that are in production, I'm doing myself a disservice and creating a scenario for configuration drift between my dev, test, QA automation, whatever. It may or may not be a realistic concern, but for example, going old school mentality, you know, for our legacy Linux systems, it's satellite to manage all of the patches and make sure everything's standardized across the board. But in going the configuration management route, infrastructure as code, managing the packages that are deployed across the board, you know, how do we maintain consistency on that front?
Okay. Yeah, so those are great questions. I worked on the operations team at Red Hat doing similar stuff, and I guess it boils down to, I think the automation bits pull you up to compliance, right? You write them into the Ansible playbooks. They, you know, run your yum updates or make the configurations to make sure you pass the, you know, the RHEL 7 or RHEL 6 STIGs or your CIS compliance. A lot of things that I think we have to kind of reset looking at this. Since Terraform and you know, infrastructure as code, I think you really need to look at your image build process probably. So like your pipelines should be producing the images, and I think the automation bits, like the Ansible bits that get you updated, are kind of like a Band-Aid until your image can be updated, and as soon as your image can be updated, then everything pushes forward to that image. So how do you roll those out? I mean, it would be, you know, that's something that you would have to discuss on your strategy of bringing servers up that are on the new image and taking servers down, but those servers that are going down have already been patched. So I think we have to kind of take it like the container approach, where everything's in there, everything's up to date, and we deploy that. And when it's not, or if there's a security problem with that, we have to build the new one and then replace the old one. And you know, if you're using scale groups or those types of things, you know, it's as easy as scaling a new scale group up or a scale set for Azure, those types of things. But we can chat after if you'd like to.
I guess along those lines, does it generally make sense to patch servers or to deploy a new image that's already patched and then kind of roll all the data over to that somehow?
If you don't have any persistent storage, yeah.
I'll move seats over here. So, no, that's a perfect question, and it's all about, you know, your workloads, how long it takes you to deploy. Some image building processes can take anywhere from like 24 to 48 hours. I would say you do not want to be vulnerable in a production system for that long. You'll want an Ansible patch. You'll want to be up to date. And then in the background, have your pipelines be producing new images. Now, if you're looking at like 3 to 4 hours, I would just recommend rolling images, because building an image, packaging it up, pushing it out into Azure or any other types of clouds is generally under like 30 to 45 minutes for us. So if we could get the software updates pulled, pushed out, then I would recommend just doing that, because then you don't have to go the extra step of writing the playbooks, testing the playbooks, and iterating over those. You can just roll your image and then start the image rolling. Again, it's kind of like the container mantra of, it's just easier these days with technologies like the cloud to down instances and bring instances up. As you saw, Terraform, very powerful, brought up an entire, you know, infrastructure system for Kubernetes in 3 minutes. I mean, how can you, your playbook startup time and your inventory parsing and everything's going to take at least that long, right? So it's almost faster to bring up the infrastructure on a new image versus trying to get all the QE out there for your playbook.
How's it looking?
It's almost done.
Good afternoon. I'm a total noob at this stuff, so I understand that with different versions of Visual Studio, you have the ability to create ARM templates. using a plugin that will basically, you say, give me a VM, and then it will put all the code in for the VM and stuff like that. With the Terraform, the way you built it here, did you do it line by line, or did you actually have something similar to that where you were able to say, give me resource 1, 2, 3, 4, and 5, and then boom, it's all in there? Because this is pretty intimidating with all the dependencies and stuff like that, and trying to figure out, what comes first and what comes second and what comes third.
Yeah, so if you architecture environment like how it want to look like, just take a simple example of not the Kubernetes but a web app. Maybe the database and everything is built into a single VM. So it's boils down to the infrastructure, like what infrastructure you want to build. So based on that, you can code like each element of your thing in the Terraform config file, like deploying VM first, then Nginx, or configuring the database and creating the connectors and everything. Yep. So you have to go by the infrastructure, like how you want your infrastructure to look like.
Right. So is that something special? Is there a plugin for Terraform in VS Code or something that you use to choose those items from?
Yeah, so if you have the extensions for the Terraform and Ansible, like the VS Code will give you the hints of what particular resource provided, like the syntax completion, X completion, everything. Yeah,
Okay.
it will highlight. And mostly, debugging like YAML files is a bit different when you have some kind of spacing or something. So it will actually bridge in to identify like what particular gaps you have in your code. Like.
Okay, so the Terraform files are YAML based then?
No, I was looking to the Ansible ones.
Okay. Oh, the Ansible ones. Okay.
Ansible.
Yeah. Okay. Thanks.
Yeah. So I think it's all built. I'll just log into one of the node to just to give you guys like. So the other copy script I was running, it was actually building the host file, which Ansible needs to identify like the different hosts in an environment. And that is located in the inventory and the cluster part. Oops, I'll just scroll this up a bit. So you can actually group your VMs in different phases, like the control VMs, the data VMs and everything. So this is how a typical host file will look like, and this will be the first control node what we have. I'll just log into this box. And I'll run the kubectl get nodes to show you guys the different things what we built. So it just built the 3 nodes in the control and the 3 VMs in the worker plane. So as I said, like this whole task, if you do it manually, it should take somewhere around 60 minutes or so, and you're not sure of how it has ended up. But after running these 2 things, like the Terraform and Ansible, you can be sure that this can be pushed to production. So this is a huge improvement if you're not using Ansible or Terraform or some kind of an automation tool in Azure. And you can also be safe, like as Ron said, like we have seen multiple customers, not only the technology companies, but also another example would be Shell. Like we recently worked on where they have end-to-end automation for using Ansible, and they don't even log into the Azure portal to do any of the deployments. The developers, their other teams just have a UI portal where they just have a click and drop, and everything gets built in Azure.
Thank you. So one of the examples we have of one of the large companies, Axon, that uses Terraform for their automation, they actually provided some feedback from their director of engineering, Hank. And I really like the quote where it says, "We use Terraform to make building our Azure infrastructure less complex and time-consuming. And we don't have to build each new environment from scratch. What used to take several weeks, we can do with Terraform in a few hours." And we found that as we share this knowledge of doing automation using Terraform and Ansible, and we have several different methods of using the tools. It's really helped a lot of our customers going to that next level. And I provided here some really useful links that if you are new and want to really get into learning how to use Terraform or learning how to use Ansible, you can go to the links, and they do have templates. They actually have videos of how to do the deployments for different scenarios so that you can start using both tools to automate your workloads. I'd like to thank you all for your time, and hope you guys enjoy the rest of the convention.
Thank you.